everyone, and welcome. So we're all just getting used to 5G, right? Well, in this explainer, we're going to look way past that and dive into the wild science and engineering behind what's coming next.
And look, that's a totally fair question. It feels like 5G just got here. But if history has taught us anything, it's that when it comes to data, we always want more. And the technologies that are just around the corner, they're going to demand a leap in speed so huge, it'll make 5G feel like old-school dial-up. So first, let's unpack why 5G, as amazing as it is, already has a finish line in sight. And it really all boils down to one thing: our bottomless appetite for data. You can see a pretty clear pattern here, right? It's like clockwork. About every 10 years, a new generation of wireless tech comes along. And each time, it's because we needed a bigger, faster data highway for all the new things we wanted to do. 6G is just the next logical and, frankly, inevitable step on that road. And what kind of things are we talking about? Well, we're not just talking about faster Netflix downloads. No way. We're talking about stuff that feels like it's straight out of a sci-fi movie. Real-time holographic calls, virtual reality that's completely indistinguishable from the real world, and something called the tactile internet, where you could actually feel things remotely. All of that needs a truly insane amount of data, delivered instantly.
So get this, the target, the big, audacious goal for 6G is 1 terabit per second. That's 1,000 times faster than the 1 gigabit speed of 5G. Now here's the kicker. Pulling that off in the radio frequencies we use today is, well, it's pretty much impossible. There just isn't enough empty space. It's like trying to fit an ocean into a garden hose. We need to find a new playground.
And that new playground, that new frontier, it has a name. It's called the Terahertz band. This is where we have to go to find the wide open spaces we need for terabit speeds. So what is the terahertz band? Okay, if you picture the entire electromagnetic spectrum, it's this huge, massive chunk of real estate that's been sitting right above the frequencies 5G uses and just below infrared light. For communication, it's been a vast, almost completely untapped wilderness. And this right here, this perfectly illustrates the big trade-off. Down at lower frequencies, signals are tough. They travel for miles and go right through walls. But the data highway only has a few lanes. Up in the terahertz band, you've got a data superhighway, 100 lanes wide. But, and it's a huge but, the signal itself is incredibly fragile and struggles to go almost anywhere. And that fragility brings us to the core conflict in this story. This amazing new frontier is actually an incredibly hostile environment for radio waves. You see, scientists have identified 4 massive hurdles. The signal just naturally fizzles out way faster. The atmosphere itself, I'm talking just oxygen and water vapor, literally eats the signal for lunch. It gets blocked by, well, almost everything. And if anything is moving, it throws the signal into chaos. I mean, just look at this chart. The amount of signal that gets absorbed by the air is staggering. At certain frequencies, the signal can lose almost all of its power after traveling just 30 feet. It really is like trying to shout through a dense fog. And it's not just the air. Because the wavelength is so incredibly tiny, everyday things become impenetrable walls. A little bit of rain, leaves on a tree, even a person walking in front of the receiver can just completely kill the signal. That means for terahertz to work, you almost always need a direct, clear line of sight. So, okay, the challenge is huge, right? It sounds almost impossible. But this is where the really cool part comes in, the incredible engineering that's being done to tame these wild, powerful waves. So the central question is this. If the signal is so weak and gets blocked so easily, how on earth can you possibly send it any meaningful distance? How do you punch through that fog? The answer lies in this really simple but brilliant analogy. You stop trying to be a light bulb, spreading your energy out in all directions, and you start acting like a laser pointer, focusing all that energy into one powerful beam. This technique is called beamforming. Because the wavelengths are so small, you can cram thousands of miniature antennas into a single device. Then, by perfectly timing the signal from each one, you get them to work together, combining all their energy to create this razor-sharp beam that can be steered directly at a receiver. It just punches right through that massive signal loss. But, packing thousands of antennas and power-hungry electronics into a tiny device is complex. So engineers are also looking at a much simpler, older technology and giving it a high-tech twist: lenses. A lens antenna works exactly the way you think it does. A special material is shaped to bend and concentrate the radio waves from a single source into that same kind of super-focused, high-energy beam. It's a much simpler, lower-power way to achieve the very same goal.
Okay, so let's fast forward. Let's assume we've solved these challenges with beamforming and lens antennas. What's the payoff? What does a world connected at terabit per second speeds actually look and feel like? Well, the applications are pretty revolutionary. We're talking about cellular hotspots that are faster than fiber optic cables. Communication between components on a single computer chip could become wireless, speeding everything up. And those narrow beams also make communications incredibly secure. It could even enable something called the Internet of Nano-Things, connecting microscopic devices for things like health monitoring. But maybe the most mind-bending application isn't communication at all, because different materials absorb terahertz waves in unique ways. The technology doubles as a high-definition sensor. It could let our devices see the chemical makeup of the air, or even use reflections to safely see around corners and through certain materials. As the source material puts it, this isn't just a small improvement. This kind of tech enables disruptive applications that will reshape the way the human work or live. It's a fundamental change in what's possible. So I'll leave you with this thought to chew on. This whole quest for 6G isn't just about faster streaming. It's about giving our technology a brand new sense. How will our lives change when the devices in our pockets can not only communicate at these unbelievable speeds, but can also see and understand the physical world around them in a way they never, ever could before? Thanks for watching. As we've seen, the journey to terahertz is really just beginning. It's going to be an incredible ride.